Hello children, welcome to Math Park. Our today's topic is trigonometrical ratios. It is chapter 22 and we are going to solve exercise 22a. From given cos A is equal to zero point 0.6, find all other trigonometrical ratios for angle A. Again, you are given cos A is equal to zero point 0.6. So 0.6 can be written as 6 upon 10. So 6 upon 10 can be simplified, which we get it as 2 3s and 2 5s. So this is 3 upon 5. So then let us again draw a right triangle again. So where A is an acute angle. So ABC. So you have cos A is adjacent upon hypotenuse. So adjacent to A is this is 3x and this is 5x. So we know that 3, 4, 5 is a Pythagorean triplet. So this becomes 4x. Now find all the other trigonometrical ratios for angle A. So we already know cos A. Then let us find sine A. So sine A is opposite by hypotenuse, so it is 4 by 5. Tan A is sine A upon cos A, or it is opposite by adjacent, so which is going to be 4 upon 3. Opposite by adjacent, which is 4 upon 3. Cot A is the reciprocal of tan A, so this becomes 3 by 4. Sec A is the reciprocal of cos A, which becomes 5 by 3. And sine A and cosec A are the reciprocal. So cosec A is equal to reverse of 4 by 5, which is 5 by 4. So tan A is equal to 5 by 12, and given that A is an acute angle. So let us draw a right triangle where A is an acute angle. So A, B, and it is right angled at C. So tan A is given as 5 by 12. So tan A is opposite upon adjacent. So opposite upon adjacent. So opposite side is going to be 5x and the adjacent is going to be 12x. By Pythagoras theorem, you get AB as 13x. Okay, now you have to solve it when it is required in the exam. Now, because it is in the shortest way, I'm telling you how to do it. So till now we use the Pythagoras theorem. By now you must have understood that 5, 12, 13 are Pythagorean triplet. So we have the first part, that is cos A. So cos A is adjacent upon hypotenuse, that is 12 by 13. Then we have sine A. Sine A is equal to opposite by hypotenuse, which is 5 upon 13. Then we have cos A plus sine A upon cos A minus sine A. So cos A value we already calculated is 12 upon 13 and sine A is 5 upon 13 upon cos A is again 12 upon 13 minus sine A, which is 5 by 13. So this, when the numerator is 12 plus 5, you get 17 upon 13. Denominator 12 minus 5 is 12 minus 5, you get it as 7 upon 13. So this 13 and 13 got cancelled. So your final value is 17 upon 7. 17 upon 7 can be written as a mixed fraction. 7 2s are 14 and 14 plus 3 is 17. So it is 2 3 by 7. We can write the value as 2 3 by 7, or we can simply write it as this fraction as 17 upon 7. So this is how we completed with question number 12. Moving to question number 13, given sine theta is equal to P by Q, find cos theta plus sine theta in terms of P and Q. Now sine theta is given as P by Q. So let us draw a right triangle with an acute angle theta. So this is our theta is an acute angle. So sine, it is opposite upon hypotenuse. So sine theta is equal to P upon Q. So this is P and this is Q. So let us find this part which is unknown. So if it is the triangle is say A, B, C is a triangle. So we find this AC by Pythagoras theorem. You get AC is equal to square root of Q square minus P square. Hypotenuse square minus this square. So we'll keep this as it is. Now find cos theta plus sine theta in terms of P and Q. So cos theta is going to be root of Q square minus P square upon Q, that is adjacent upon hypotenuse. Now let us find cos theta plus sine theta. So cos theta plus sine theta is going to be, cos theta is root of Q square minus P square upon Q, plus sine theta is going to be P upon Q. So when we add this, because the denominator is same, so we just add the numerators. So which we get as the numerators when we add P plus root Q square minus P square, and upon Q will be written just once, and that's it. We are done with the answer in terms of P and Q. If cos A is equal to half and sin B is equal to 1 upon root 2, find the value of tan A minus tan B, 1 plus tan A tan B. Here A and B are from different right triangles. So let us take this right triangle as say A, B and C, and this is another right triangle A, B and C. So first for you have cos A. When we are talking of cos A, so this A is of this triangle. So cos A is adjacent upon hypotenuse. So this is 1 and this is 2x, 1x and 2x. And when we are talking of sine B, we'll be using another triangle. So sine B is 1 upon root 2. So it is x and root 2 is the root 2x becomes the hypotenuse. So we are now asked to find the values of tan A minus tan B on this. So let us find the third side. So we have BC for this first triangle is equal to root of 2x the whole square minus 1x the whole square. So which is 4x square minus x square, that is root of 3x square, that is root 3x. So this is your root 3x, and find BC for the another triangle. For the second triangle, if I am finding BC for the another triangle, so this is going to be square root of root 2x the whole square minus x square. So which is 2x square minus x square, that is equal to root of 1x square, that is root x. It is going to be simply x. So we found this. Now tan A when we are talking, so we are talking for the first triangle. When we are talking of tan B, then we are talking for the next triangle. So when we are finding tan A for the first one, so tan A is opposite upon adjacent, that is root 3 upon 1. So we have root 3 upon 1, that is root 3 minus tan B when we are using tan B for this, which is opposite upon adjacent, that is we are getting it as 1 x upon x, which is 1 upon 1 plus tan A tan B, that is 1 plus root 3 into 1. So 1 plus root 3. So now we will be rationalizing the denominator. So we have, since it is when I'm going to square it, it is going to be 1 square minus 3 square. So I'll rearrange this first of all. So which can be written as root 3 minus 1 upon root 3 plus 1. Now we will rationalize this. So root 3 minus 1 upon root 3 plus 1. Plus 1. So the rationalizing factor is root 3 minus 1. So root 3 minus 1 upon root 3 minus 1. So this we get it as denominator is going to be a square minus b square, that is root 3 square minus 1 square, which is 3 minus 1. A minus b the whole square. Here it is root 3 minus 1 the whole square upon root 3 square minus 1 square. Root 3 minus 1 the whole square is a square, which is root 3 square is 3 minus 2ab, that is minus 2 root 3 plus b square, that is plus 1. So which is 4 minus 2 root 3 upon 2. Take 2 common from the numerator. So 2 in bracket 2 minus root 3 upon 2. So which 2 and 2 got cancelled. Our final answer is 2 minus root 3. That's it. Theta is equal to 12. You get cot theta is equal to 12 upon 5. So let us draw a right triangle with an acute angle theta. So this is your theta over here. So cot theta is adjacent upon opposite. So this is your 12x and this is your 5x. So by Pythagoras theorem, we get this as 13x. Now cosec theta is equal plus sec theta. So we have cosec theta plus sec theta we are asked to find out. So cosec theta is hypotenuse upon opposite. So it is 13 upon opposite to theta is 5 plus sec theta is hypotenuse upon adjacent, so which is 12. So take the LCM of 12 and 5, it is 60. So we'll have to multiply by 12 here. So 12 into 13 is 156 plus 13 5s are 65. So 156 plus 65 is 5 plus 6 1, 6 plus 1 7 plus 5 12, carry 1, 1 plus 1 2, 221 upon 60 equal to, when I find the mixed fraction of this, 6 4s are 24, 6 3s are 18. So 16 to 3 is 180, 180 plus 41. So this is how we get 341 by 60. Question number 16, if tan x is equal to 1, 1 by 3, find the value of. Okay, so tan x is equal to 1, 1 by 3. So 3 ones are 3 plus 1, which is 4 by 3. So again, let us draw a right triangle where x is an acute angle. So this is an acute angle. So tan x is opposite by adjacent. So this is 4 and this is 3. So by Pythagoras theorem, we get this as 5x. Okay, so this is 3x, 4x, and this is 5x. Now let us find the value of 4 sine square x. So we put the values, let us write 4 sine square x minus 3 cos square x plus 2. 4 sine x is going to be opposite by hypotenuse, that is 4 upon 5, and then the square of this, minus 3 cos x is adjacent upon hypotenuse, that is 3 by 5 and the square of this, and then plus 2. So 4 square is 16, 16 fours are 64 upon 25, minus 3 square is 9, 9 threes are 27 upon 25. So 64 mine and then plus 2 is there, plus 2. So 2 upon 1. So we'll take multiply by 25 here so that the LCM is 25. So the denominator is 25. So we have 64 minus 27 plus 50. So which we get it as 64 minus 27. 64 minus 27 is 37 and 37 plus 50 is 87 upon 25, which can be written in the mixed fraction. 25 threes are 75 and 75 plus what gives 87. So we get this as 312 by 25 is our final answer for this question number 16. Question number 17, if cosec theta is equal to root 5, find the value of 2 minus sine square theta minus cos square theta, 2 plus 1 by sine square theta minus sine square theta, cos square theta upon sine square theta. Okay, so theta is, cosec theta is root 5, so which can be written as root 5 upon 1. We can write as root 5 upon 1. Let us draw a right triangle where theta is an acute angle. So cosec theta is hypotenuse upon opposite. So this becomes 1x, hypotenuse upon opposite. So let us find this one by Pythagoras theorem. So let us name it as ABC. Okay, so you get BC is equal to square root of root 5x ka square minus 1x ka square, which is x square. So which we get it as 5x square minus x square, which we get as root 4x square, that is 2x. So we got this as 2x. Now let us find the values of the sine square theta, cos square theta. So we start with the first part, 2 minus sine square theta. So sine theta is 1 by root 5. So we have 2 minus 1 upon root 5 and then the square of this, minus cos theta is adjacent upon hypotenuse, that is 2 upon root 5 and then the square of this. So let us simplify this. 2 minus 1 by 5 minus 2 square is 4. So 4 upon 5. When we take the LCM, let us keep this 2 as it is. So we have minus 1 by 5 minus 4 by 5. So which is minus 5 by 5. When I add this, I'm getting minus 5 by 5. So minus 5 by 5, which is minus 1. So 2 minus 1, that is 1 is the final answer for this part. So we have 2 plus 1 upon sine square theta. So 1 upon sine square theta minus cos square theta upon sine square theta. So 1 upon sine square theta. Sine square theta is equal to 1 upon root 5. So 1 upon sine square theta is going to be root 5. So this becomes 2 plus root 5 and then the square of this minus cos square theta upon sine square theta is tan square theta. So you can remember, sorry, cos square theta upon sine square theta is equal to cot square theta. So cot theta is, so which is going to be cot theta upon opposite, that is 2 upon 1 and then the square of this. So we have this as 2 plus 5 minus 4. So 2 plus 5, that is 7 minus 4, which is equal to 3 is the final answer. Got it? Question. So let us again draw a right triangle over here. So drawing a right triangle where A is an acute angle. So this is your acute angle ABC. So sec A is root 2. So we'll write as a root 2 upon 1. So hypotenuse is root 2 here. So this is going to be 1 and 1. So now let us find the value of cos A. So cos A is 1 upon root 2. So 3 into 1 upon root 2 and then the square of this plus 5 tan square A. So tan square A is 1 square. Tan is opposite upon hypotenuse. Sorry, opposite upon adjacent. So this is 1 square upon 4 tan square A. That is 4 into 1 ka square minus sine square A. Sine square A is going to be 1 upon root 2 again. 1 upon root 2 and then the square of this. So let us put 3 and 1 upon root 2 square is 1 by 2. So plus 5 upon 4 into 1 square is 4 minus 1 upon 2. So 3 by 2 plus 5 upon 4 minus 1 by 2. So 4 minus 1 by 2. Here the LCM is 2. So 5 2s are 10. 10 plus 3 we get 13 upon 2 upon 4 2s are 8. 8 minus 4 2s are 8. 8 minus 1 is 7. So 7 upon 2. This 2 and 2 will get cancelled. We are getting 13 upon 7, which can be written as 7 ones are 7. And 7 plus 6 is 13. So 1 6 by 7 is our final answer. If cot theta is equal to 1, find the value of 5 tan square theta plus sine square theta, 2 sine square theta minus 3. Now again this is an easy, cot and tan are reciprocals. So if I'm taking this as theta, so this is 1 and 1, this is going to be root 2. So tan square theta is also going to be 1, tan theta is also going to be 1, sine square theta is 1 upon root 2. So 5 tan square theta is 1, so 1 square plus 2 sine square theta is 1 upon root 2 and then the square of this minus 3. So 5 into 1 square is 5 plus 2 into 1 upon root 2 square is 1 by 2 minus 3. So this becomes 2, 5 plus 1 minus 3. So 5 plus 1 minus 3. So 5 plus 1 is 6 minus 3, which is 3. This is how we get the final answer as 3. Got it? Question number 20, the last question of this exercise. In the following figure, you are given AD is perpendicular to BC. AC is given as 26. This AC is given as 26. CD is given as 10. BC, BC is 42. BC is complete 42. So if BC is 42, BD is going to be 42 minus 10. So this is 32. Then you have angle DAC is equal to X and angle B is equal to Y. Find cot X, 1 upon sine square Y minus 1 upon tan square Y, 6 cos X, 6 upon cos X minus 5 by cos Y plus 8 tan Y. Okay. Now let us find the unknown sides. So we will be first finding AD. So we get AD is equal to square root of 26 square minus 10 square. So that is 26 square is 676 minus 100, which is root of 576, that is 24. You got AD as 24. Now let us find AB. So you have AB is equal to root of 24 square plus 32 square. So 24 square is 576 and 32 square, let us do 32 into 32. Calculate it mentally, or you can write it. 32 square is 1024. Add 1024 plus 576. So plus 576, we get it as 1600. So this is 1600 and square root of 1600 is 40 because 16 square is 4. So this is how we got this as 40. Now let us find the first part, that is cot x. So cot x is equal to adjacent upon opposite. So adjacent is 24 and opposite is 10. So it is 24 upon 10. You can write 24 upon 10 or you can write 2.4. Second part, you are asked to find 1 upon sine square y. So 1 upon sine y. Now sine y is opposite upon hypotenuse. So you have sine, let us write sine y first of all. It is 24 upon 40, which we can simplify 4 8 threes are and 8 fives are, so 3 by 5. So we are getting sine y as 3 by 5. Let us find tan y. So tan y is going to be opposite upon adjacent, that is 24 by 32. So 24 by 32, 8 threes are 8 fours are 3 by 4. Put the values. Now we have to find 1 upon sine square y minus 1 upon tan square y. So 1 upon sine square y is going to be the reciprocal of that. So it is going to be 5 upon 3 ka square minus 1 upon tan square y. So we'll take the reciprocal of this. It is 4 upon 3 and then the square of that. So 5 square is 25 upon 9 minus 4 square is 16 and 3 square is 9. 25 minus 16 is 9 and 9 upon 9 is 1. So we got this as 1. Now we will be doing the last part of this, 6 upon cos x. 6 cos x. So let us first find cos x. So we have cos x is equal to adjacent upon hypotenuse, that is 24 by 26. 24 upon 26 is 12 upon 13. And then let us find cos y. So cos y is equal to, cos of y is adjacent upon hypotenuse, that is 32 upon 40, which is 8 fours are and 8 fives are 40, so 4 upon 5. Then we have to find tan y. So tan y is opposite by adjacent, that is 24 upon 32. So 24 upon 32 is 8 threes are 8 fours are 3 by 4. So let us substitute the values here. 6 upon cos x. So 1 upon cos x. So it is going to be 13 upon 12. So it is 6 times the reciprocal of 1 by cos x. So we'll take the reciprocal of this. So this becomes 13 by 12 minus 5 cos y. So we'll take the reciprocal 1 upon cos y. So we'll take the reciprocal and multiply. So it is 4 by 5. So this becomes 5 by 4. Okay. And plus 8 tan y. So tan y is 3 by 4. So 8 times 3 by 4. So let us simplify this. We have 6 ones are and 6 twos are 12. 4 ones are and 4 twos are 8. So we have here 13 by 2 minus 25 by 4 plus 3 twos are 6. If I take the LCM to be 4, so let us take the LCM as 4. So 2 twos are 4. So 13 twos are 26 minus 25 plus 6 fours are 24. So 26 minus 25 is 1. 1 plus 24 is 25. So we get this as 25 by 4, which can be written as 4 6 are 24 plus 125. So 6 1 by 4 is our final answer. So children, if you understood and if you like it, please share with your friends. Coming up with the next exercise. Thank you for watching. Have a good day.